Hello, hello. Let me check if the voice is fine. Okay, looks good. Okay, hello everyone, and welcome to this third part of Q-Learning series. Today I want to continue where we stopped yesterday, but before we start I have some good news. I have a Sharpie actually today. So if we need to explain something, I will actually have a Sharpie, so it's going to be a bit more clear what I'm writing in there. Let me take this off. Okay, so let me actually do a quick recap of yesterday here. Just make my picture larger first. Okay, here we go. So what we did yesterday, we had an environment and we had an agent. The environment produced two things actually. It produced a set of states, a set which is the state, like a vector, which is the current state of the environment, and the agent used some policy, let's call it pi for now, to decide which action to use. So it will pick one action and it will perform that action on the environment. The environment will send back a reward based on the action we had in the environment. So we already have some code in here for the environment. We have some code for the agent, and I will go over that code quickly now to explain where are we. Okay, I'm really happy with this Sharpie. Okay, so let's look at our code. Oops, I'm not doing this right. Okay, there we go. So we have two files now. We created a package called QL, short for Q-Learning, and we have two files inside. We have agent and we have environment. Let's look at this one. Let's actually start with the environment. It will make more sense. So sorry. And I'll do this. I'll go to environment. Oh, okay, this is not fun. I'll go to environment. Oh wow, this is even worse. It wouldn't be me if I didn't mess up these simple things. So this is the environment. Inside the environment I have two private variables. One which is the state of the environment, the current state of the environment, and which step in our simulation are we in. I hard-coded a couple of things in here. This is a deterministic environment, so there are no different outputs for different inputs. This is not even a temporal thing. Doing something wrong does not affect the environment anything. So the agent's actions does not really affect the environment. It doesn't change anything about the environment. We're just trying to solve XOR Gate. If you're not familiar with what's XOR Gate, I will also do a quick recap in here. So XOR Gate looks like this. So 0 0 0 1 1 0 1 1 0 0 gives a 0, this gives a 1, this gives a 1, and this gives a 0. So this is my state, and I have two possible actions, either 0 or 1. Right now I want to build this pi policy in here, which receives some kind of input, which is as a state, and it will decide to build a policy. It will put all the actions in here. So this is our pi. I will have 0 and 1. and I will be initializing everything to 0.5. So this is my value function. My value function will read this table as the way it decides which action to take. So 0.5, 0.5, 0.5, 0.5, 0.5. Again, sorry, this is not fun, but I initialize everything to 0.5, which is somewhere in the middle. So there is no preferred action anywhere in here. It will just pick one of them. As rewards come back from the environment, the agent will start adjusting this policy to determine which action it should take based on a reward that it receives from the environment. Okay, so this is what we are doing today. I'll go back to the code in here. Okay, so again, these are the states, these are the actual correct answers in here. I have a method in here called getState that returns one state from this state list, and the state it will choose is the first one, second one, third one, fourth one, then go back to the first one, second. So it will not choose one randomly, it will actually pick them in series, and it will just keep repeating them. So this is why our state is basically just one state from the state list, and we're using the step modulus 4 to keep looping basically through these 4 states. And here, get actions, it will show me what are the possible actions at the current state. So I will get the current actions, and finally in here, this method will perform an action on the environment. So it will receive the action as a parameter, and it will return the reward as a float 64, and we did the math here yesterday. So it will give negative reward for bad things, but it's giving 0 reward for good things basically. So we want to change this. So what I will do in here, I will make it 1 minus, then I will put all of that. 1 minus. So yesterday we had this, which was giving us a reward of 0 if it's good and -1 if it's bad. If we add a 1 to that, this will return 1 in case it's a correct answer, and 0 in case it's the wrong answer. Actually, let's write this as a comment in here. Returns 0 if wrong answer, and 1 if correct. Okay, what we're going to be working on today is the actual simulation. So how I imagine this to look like, it's going to look something like this. The environment, let me go back to the to this. So how I imagine this to look like, let me just use another paper here. Yeah, I imagine an environment with the agent actually inside the environment. So the agent is inside the environment. With this kind of mentality, think about the problem, we can do something later called multi-agent environments, where we can have multiple agents competing together or working together or doing something. But this is how I imagine the library to look like right now. So let's go back to our code and convert that idea into code. So I would start doing another method in here. It takes pointer to environment as a receiver, and it will be called start simulation. Start simulation, one word. Then I will call it, and we'll get something called steps. So how many steps do I want to perform? and I'll make this into an integer. Okay, so I could start a simulation and do one step by just passing 1 every time. I will do a few more things in here, func, and I will do e, also receives pointer to the environment, and it will be called reset simulation. So reset simulation, it's a method that resets the simulation. So e dot step equals 0. E dot step equals 0. Nice. Now the last thing I want to do inside the environment is, since the agents are inside the environment right now, I will have a list of agents in here. So I will do agents, which is an array of agent. Actually, I can make it an array of pointer to agent, which is a bit better, I guess. Actually, it doesn't really make any difference because we're already dealing with a pointer of the environment throughout our complete simulation. So start simulation. Start simulation will do something here. So it will do, it will repeat some process several times. So for I equals 0, I is less than steps, then I plus plus. So I will repeat some process step times. So number of times equivalent to how many steps do we want to do. Some code is gonna go in here to do the actual agent's work, so the actual step code in here, but after that I will increment so that code will go in here and increment step. So I will increment the step inside the environment, e dot step plus plus. So every time I do one of these, it will increment the step until it finishes the whole thing. For debug now, just to make sure that this whole thing is working, let's do a couple of things. So I will just call debug lines, and actually I need to print a bunch of things, so let me import font or font, actually, whatever. It's because it's short for format. So anyway, font dot I guess println. Oops. Dot println. Okay, and I will print in here. I will say step. I guess I could use something else. It's okay. Step. Then I will pass the e dot step. So if I start a simulation, it's just gonna do it will print step 0, step 1, step 2, step 3, step 4. So instead of making it sound like step 0, I want it to be step 1, so I will just add 1 in here. And now we have something in here that we can test. The last thing I want to do, I want to fix something inside the agent. And let me go in here. I had a bug in here yesterday, so I was doing this yesterday where I'm picking an action and receiving the reward for that action, and I guess I don't want to perform that in here anymore. What I want to do now is I will just return the action as is, without actually performing the action on the environment. So the agent actually does not change the environment. The environment sees what action does the agent want to do, and it will perform it on itself. Okay, so we have that part sorted out. Let's go back to environment. Now I will do something quickly in here. Let me just make this a bit bigger. Okay, so I'll go out and I will make a new directory, and I will make a new project that tests our library. So I'll call it, I'll call this one, I don't know, XOR. cd XOR, and I will do vim main.go. In here it's called main. The package is called main because this is an executable application. The other one, the package, is not called main, it's called something else because it's not executable. So that one we cannot really execute. Anyway, so I will import my other library in here. I will do this, and I will import it here, github.com/hardware/ql. Okay, and instead of that I will say something like starting XOR simulation. Okay, and I'll do ql dot, and let me do to complete in here. It's unable to actually see my anyway, I will do this ql dot and ql dot agent and environment. So I will build one environment for now. I'll call it env also in here. env is an environment, and then I will do env dot start simulation. So I will start this simulation and I will do 10 steps. Okay, cool. Let's test this quickly. And bigger, go build and XOR. So let's compile it and run it, and we can see starting XOR simulation, step 1, step 2, step 3, step 4 until step 10. So the basic thing is working now. Now we can go back in here and start doing actual things with our simulation. So the set simulation part is there already. We didn't test it, but we know it's just a simple thing. Anyway, the actual step is going to look like this. It will in here I have a list of agents, but in this scenario I have a single agent, so I will just get this agent. I guess I could get the agent outside the loop. So a equals env dot agent, I guess it's small, was it? Yeah, agents is small letter, so it's a private thing in here. Agents of 0, and I will do things with this agent in here. So I can do a dot why it doesn't like to complete this part. env that, oh, it's unhappy with vim is unhappy with me trying to get it to do autocomplete. It's okay, this is kinda something happened. Oh wow. Anyway, okay, a dot this is weird. Let me just save it first. Oh, that's why it's not called env. The actual variable name is just e for environment, so e.agents. Yeah, should work now. And a dot, yeah, thank you. So I will e dot action, no, this is the actual environment. So choose action. So basically I will make the actual code that does everything, I will make it in here. So choose action will give me an action. So I will pass my current state. I will do e dot, and the same step we did there, I will redo it in here because I will make that part not right, choose action, choose action. Choose action receives a state. Choose action receives a state. So yeah, I'll just I'll do it from scratch in here. It's actually it's e that gets state. Wow, didn't realize. E dot get state. Nice. That returns a state for me, and the agent will pick an action based on the current state, and I will call this action equals this agent that chooses action. Then I will perform this action basically on the current environment. So I will pass this action in here. Action. Yeah, I'll do this now. E dot action, perform the action that came from the agent on the environment, and that will return a reward. So let's call it reward equals the return of the action. Now we're gonna have to add something to the agent to tell the agent this is the reward that you received. So I will do finally something called a dot reward, and I will pass that reward to the agent. Sorry, I will pass reward in here. Okay, nice. Now I can go back to my agent and implement this new method called reward. Func a agent reward, and I will pass the reward in here as r float 64. And now we're going to implement our learning formula basically. So the learning formula looks like this. If you remember, in here we had this thing. We initialized our policy in here to everything equal to 0.5. Now if I received a reward, I will add that reward to my policy in here. So let's say I received a reward of 0. 0 is not negative, so it will not reduce it. So I guess I could convert my range from 0 to 1 to something that works with my policy. I will make it -1 to 1. The way I will do this, I will multiply this by 2, then subtract 1 to change this range from 0 to 1 into a range that goes all the way from -1 to 1. So just to expand it a little bit, I will multiply it by 2, then subtract 1. So first thing I will do is reward equals reward times 2 minus 1. So now I have a reward that where the range goes from -1 to 1. Now next I will use a function to update my table. So my table in here, whatever the reward is, I will add that reward to my policy, to the policy that I use to pick which action I used in here. So let's say I received the minus policy, so I could subtract the -1, the whole -1 from this, but this is not what I'm going to do. I will use something called a learning rate, which is denoted by alpha in here. We'll use something like 0.1. So if I received a -1, I will use only a 0.1, a -0.1 as my increment to the policy in here. If I receive the 1, it will be a 0.1. So the policy will slowly converge into the optimal policy. So in here I will actually change one thing about my policy. I was thinking about it since yesterday. I did not like what I did in here. So in here I had a single number. So policy is a map that has a key of 2 integers, which is the state basically, and the return of the policy is a single number. But if we look in here, our state is 2 numbers, and our policy, our actual policy, is again 2 numbers in here. So let me switch to the code, and I will when we'll look at this one. In here, I will change this part to make it an array of 2 of float 64. So in here, I will also convert to this one, float 2, and instead of this looking like this, I will do in here 2 float 64 of 0.5 and 0.5. Yeah, so 0.5, 0.5. I'm initializing the policy to the 0.5 thing that we had in here. Okay. Now I could actually look at this part, and I'm looking for the largest number in here. What's the largest value that I could end up getting, and I'm going to return that. So I'm going to change this part into a policy that gets me the largest number. So I will loop over this one. So I will do action equals -1 in here, and I will do for I don't know, I equals 0, I is less than 2, and I plus plus. Oops, I plus plus. So I will loop over these things, and I will choose the highest reward that I think I will get. And here I will do, actually I could do this in a single line. I could do something like this. If, because it's only 2 things, I will do if the policy of s of 0 is larger than the policy of 1, then return 0. Then return, I guess I could just make action equals 0, else action equals 1. This is kind of weird code now, so I'll just make it 1, then I can remove this whole thing. So if 2 is if this is larger than this, then it will return 0, otherwise it will return 1. Okay, perfect. Not really perfect. Why? Action. Why it's unhappy with this? Expected something. Oh yeah, sorry, forget this. Okay, cool. Now it's also unhappy with this for some reason. Oh, it's just called R, not called reward. That's just called R. So R equals R times 2 minus 1. Then I will use our alpha in here. I will define a learning rate. I got alpha equals 0.1. I will hard code it, and I will update now my policy that led me to this. Then I have to do the same thing where I find out which action I used and which step in our policy we're in. So I guess I should pass the state that I'm in here, so I can update to that state. I can update the current state basically. So I'll do s, which is and so I will pass my state and my reward in here. So I can do in something in here, then I can do my reward is this right now, R times 2 minus 1. Then I have an alpha, which is my learning rate. I'll just comment it here, write a comment in here, learning rate, and finally I will update my policy. So I can do a dot policy. Hello Albert, sorry, I really did not notice you. I was immersed in coding. How are you, Albert? Albert is like one of my oldest friends since I started doing anything with machine learning. So I will go back in here to my policy, agent dot policy, then of policy of state plus equals r times alpha. So I will add my learning rate, my reward times the learning rate into my policy. So if this was 0.5, let me just go back to cam view for a second here. So if this was 0.5, it will be reduced to 0.4 if it was the wrong answer. If it's the right answer, it will become 0.6. So the policy will slowly converge into the right policy. Now I can save everything in here, and I guess I could go back to code and a dot does not like a dot policy for some reason. S to end. Wow, this is kind of weird. Let me build this just to know what's the actual error. Invalid operator plus equals type. Yeah, sorry. I should find out what action did I use to get to that reward. I guess I could also pass the action in here, so I really don't have to redo anything. I guess I could do a, or I'll just call it action, which is an integer. Okay, so I have action in here, and then I can update that part alone. Of I'm not really sure that you can do this. Of action, I mean. Of action. I'm not really sure you can update him. Yeah, I'm not sure this is possible. Let me see. And not enough arguments to call reward. Oh, okay, that's fine. Cannot assign to. Yeah, you cannot assign to this because it's an array element inside the map. So you will have to actually keep it somewhere in here, then assign the whole thing back. So I can do something like wait, I can do it in a nicer way. Let me get to this part out first. I'll call it P, short for policy. So I have P in here, and I can do P, oh sorry, not of action, P of action plus equals R times alpha. Okay, so now I updated this part. I'm not really sure you have to assign it back, but just to be sure, I will assign it back. Maybe someone smarter than me can actually tell me we don't have to do that. But we're running out of time in here already, 3 minutes over our time for the stream. So I'm just making sure the reward part is working. So let's run this. Let's run this and see what kind of results are we getting from our simulation. So I will go back to my environment, and actually the last thing I have to do in here is update this part. So the reward actually should get back the where is it? It should get back the step. Oh no, where is it? Where is the part that's selecting which state to send? Oh, actually it's called get state. So I guess I could just call get state again in here. I think reward had 3 parts. It received first the state, the action the agent chose, and the reward. So get state is not working for some reason. Let's compile just to know what is the actual error. Get state, oh, okay, get state actually returns a different type in here. So I guess I could do it again. This is a slice and the other one is an array. I'm not really sure you can cast it. Let's try to cast it. Why not? Let's see if we can cast it. I'm not really sure this is even possible. Nope, that's not a thing. You cannot actually cast this into this. Okay, that's fine. I can just redo this from scratch. So I can do state equals to end of get state of 0 and get state of 1, and I can just pass this as the state. Okay, this is dragging for much longer than what I hope to do. So now last thing is, let's try to run this again just to see if it's gonna be working. Of course it's not working. Index out of range 0 with, oh yeah, I don't have any agents actually. I don't have any agents inside my simulation, so let's start by creating one agent. So e dot agents equals an array of agents of agent, where I will initialize just one agent inside. Let's see. Okay, it's going through step 1 to 10. Now let's see what is the reward that we're getting and how is the policy changing. So I will show what's the reward in here. I'll just print it. Temp.println reward as reward. Cool. Now let's see. Reward 2 1 1. This is weird. What is this reward? Why is the reward 2 and 1? Let's go back to reward in here. Where's the reward coming from? E.action. Okay, E.action is 1 minus the reward times minus 1. So it should return 0 and 1, not 1 and 2. Not absolute step minus a. Have something in here that's not right. So the a might be the problem here, or the answer is either 0 or 1, so there isn't much in here. I guess I could just add one more debug line here quickly just to see. Temp dot println, and I will do a as something, I guess, then a, and then I will add, I guess, the A and the answer. Yeah, let's just add both of them, and I'll just call it answer is the actual answer. Okay, then I will also pass the R finally. R is R. Okay, let me quickly run this and see what's happening. Dun, 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 dun. Okay, so when my action is 1, I should have got 0. My reward was 1. When it was 1 and 1, my reward was 0. So this was the error basically. Okay, let me go back in here. Times -1. So let's do the times -1 in here directly. Times -1. So I can remove the times -1 from here, and I can do 1 minus r. And let's run this one more time. Yeah. So now I have -1 minus 0 minus 0 minus 1 minus 1 minus 0. Okay, so I have minus 0 is basically 0. So I'm receiving a -1, so I should add 1 to that now. So I will just do, actually not this, I'll add 1 to it. So I will do times -1, then I will finally do +1. Nice. So now if we run this one last time, we should get the nice results. Okay, reward is 0, reward is 1, reward is 1, reward is 0, reward is 0. Actually, this was learning definitely the wrong answer to everything. Nice. Oh yeah, because this part is wrong, so I should return just r in here, and should be fine now. Yes, you can see in the beginning I got reward of 0, reward of 1, reward of 1, reward of 0. I started learning after it finished the first iteration, and you can see my reward was just correctly. It kept guessing everything correctly. Now we can finally, after we have all of that done, I can print my policy. I'm sorry I'm 10 minutes over the time, but just a quick last thing. Let's print our policy, and I will go in here quickly and I'll print my policy. So once I'm done with the simulation, I'll do femd femd.println, and I will literally just actually print f, and I will print my policy. So my policy as, I will just do this, and I will do this, and so policy new line, then this is a placeholder for something that I want to pass in here, and I will pass a dot actually the agent dot policy. Nice. So now let me just delete the extra debug lines. Where are the other debug lines that I added? Yeah, let me just delete those, because we're just gonna clog the screen now. Okay, and run this one last time, and you can see nice. Step 1, the reward was 0. Why reward has double A? Anyway, reward was 0, then 1, 1, 0, then after one iteration it learned and the right policy. And if we look in here, we can see the policy. So when the input is 0, 0, the policy says you might get 0.7 if you return a 0 and 0.4. So you can see that it started learning the right policy in here. And you can see for 0, 1, so for 0, 0 it should return as 0. And yeah, you can see 0 is higher than 1. For 0, 1, you can see 1 is higher than 0. 0 is 0.5 and the other one is 0.8. So it's learning the right policy in here. The third one is 1, 0. It should return also a 1. We know that. So 0.5, 0.7 is higher than that. So it should return a 1. And for this one, it should return a 0. We can see the reward, the expected reward for 0 is higher than the expected reward of 1. And that's the simplest version of Q-learning with like XOR simulation. Next, I might move tomorrow to another example in Q-learning where we do something different. This was good, no worries, no time. Thank you very much. Code will be on GitHub. I will publish definitely this code on GitHub EV. And if you have any questions, you can ask them to me on Twitter. I'm always available there, or you can just send them during this live stream. But tomorrow, I guess I will move directly into. Actually, I might move into another example tomorrow, something in the middle between like all the way trading stocks and XOR, something in the middle. We will try to solve a maze or something. Okay, thank you so much guys for showing up, and sorry for keeping you for another 15 minutes. And I guess I will see you next time. Bye guys.